Hi, my name is Alberto Rubio, Vice President of Professional Services at Clear Sky. This demonstration I'm going to walk you through today is trying to answer a question that a lot of people have. These are companies that are trying to get into the real estate part of wireless networks. So today there's currently tower operators, for example, American Tower, Crown Castle, and others that lease back real estate to wireless operators to mount their wireless RAN assets. Those could be macro cells, small cells, etc. And what they do is they go and they wait for the wireless operator to come to them and say, well, we have a need in this area. We either have poor performance or we need to offload capacity. What do you have in that area that we can mount some sort of solution on? And then these tower operators will go and say, well, we have these different things. The problem with that model is that it is very reactive. You have to be at the mercy of the wireless operator to tell you that they have a need in a certain area, then you go look. And it's very difficult to run a business that way. It would be a lot better if you could be proactive and say, look, AT&T or T-Mobile, I know you have issues in this area and these are the assets I have. Would you like to sign up? And then if you could even take it a step further and say, here's a solution that you most likely need, then you turn it into more of a full turnkey solution. And then you're being proactive, not reactive. And that's probably a better way to move that business forward. But the question is always, how do we know where an operator could potentially have issues either related to the capacity side where they need to offload traffic, or performance, or a combination of the two, or maybe even some other objectives that people really haven't thought of, which do come into play, which are things about marketing. So if I'm the wireless operator, it's not just about the technical side of things. You might also have questions about, well, all things being equal, what is this worth to you? Is this in a high income area versus a low income area? Is this more beneficial because there's more enterprise locations than residential locations? So what I'm showing here on the screen is a demonstration around how to use many different data sources, and what we do is a lot of big data and a lot of analytics kind of mixed with the wireless, taking into account the technical side, to really try and understand that and come out with some answers and be proactive in this sense. So this demonstration revolves around this triangle right here. There is a point here. We're in Boca Raton, Florida. There's a community center here. And the question is, we would like to see if there's an opportunity to lease back this community center in some way, shape, or form to a wireless operator to help them their network. And the operator has given us no data. We're doing this all on our own with our own data sets. So let's start off with traffic first. So the first thing to understand is really, what does traffic look like in the area? So if you just follow me around the screen here, there's several different traffic data sets that we look at. So these are all empirical data sources. We pulled about 2 or 3 here, and we combine all these, and they all sort of show a different picture. So the first one I'm going to turn on is smartphone user data demand. So this is actually coming from smartphones. This is coming from the GPS of smartphones. And I'll just zoom in here close to this community center. And this is a Bing map underlay, so it's a little slow loading up. And the way this legend works is that these purple points really represent slow traffic, and as you start getting higher up in the heat map, you go to the greens and then the yellows and then the reds, which is higher levels of traffic. So there's a few things that stand out. I'll just zoom in over here and see what's here. So we can see, for example, this is a shopping center. There's a store right here. There's a lot of people in front of this store. There's a building right here, which there's a lot of people inside that building doing data traffic. Same here. I'm guessing this is probably going to be some sort of restaurant. This building here, a lot of data traffic, a lot of data traffic here. Even outdoors on the street, you can see people at the intersection. I'm guessing there's people stopping at a red light, and what do? If you look over, they're all on their phones. This store. So this really gives an indication of where there is traffic, people doing something on their smartphones. If I go closer to this community center, there's not a whole lot around here. You have a bit of traffic over here, something over here, but nothing significantly close to this that pops out as immediate traffic offload. But let's look also at maybe a different data set. So I'm going to turn on this one called venues. And there's a traffic map within this as well. This data set is also a traffic map. This is looking at the name of these locations, who is in these locations, how many people are there. So if I go back to my example up here in the shopping center, if you remember, this building was really hot, and we said there's something in here where there's a lot of people doing something. We can actually start quantifying. So this is a McDonald's, for example, and this one right here, if I click on this, let's see what's here. That's a Starbucks, and in that Starbucks there was 3,605 people over a certain time frame, and it looks like there's less people doing something. So at the McDonald's, even though there's a lot of people, there was only 1,135 people in the same time frame. So the idea is that there's triple the amount of people doing something on their phone in the Starbucks versus the McDonald's. There's another point, Panera Bread. And so that's the way this traffic map works. We can also look at enterprise, for example. So I'm going to turn on this enterprise heat map, and let me turn off some of these other layers, and I'll zoom out. So this heat map is looking specifically at enterprise locations. So that could be doctor's office, dentist's office, a store, a shopping center, etc. And we can also turn this on by building. There's of course a traffic map that we put on, and these dots are all representative. If we look at the legend here, you can see red means there's a lot of traffic, and blue means there's lesser amounts of traffic. And let me just zoom out to this entire layer. And so you can see within this area of interest, there's a lot of different enterprises that we pulled and that we're looking at. And you can start seeing the concentration. If I start overlaying all these maps on top of each other, statistics tells us that things are going to correlate. You can see the correlation here, 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 and here. Now, if you remember over here, this area didn't look that hot when we had pulled up just the smartphone data traffic. But when we put the other data sources, things definitely start to pop up right here. Okay, so that's a view of traffic. So that's one way you could go to a wireless operator and say, well, here is the traffic out there. This is all traffic basically. This could be Wi-Fi as well as licensed spectrum. But the idea, statistics tells us that if Verizon has 25% market share, within these hotspots, 25% of that is going to be your traffic. So relatively speaking, there is a lot of traffic where there is traffic. Whether or not it's yours will all depend on your market share. Okay, the next thing we'll evaluate here is network performance. Now this one is a bit tricky to look at, because typically what we do is when we do projects for wireless operators, they give us their network topology and we model what is coverage, what is signal strength, what is interference, throughput, etc. Without their specific information that we use to model that, we have to rely on other data sources. So these data sources are not altogether 100% complete. There are clients that people use on their phones that measure the performance of their operator, and it reports it back, and we basically pull those. But it's sort of incomplete. What you see is a lot of people reporting things on the roads, but not necessarily indoors or in a lot of every kind of ubiquitous locations throughout the network. So I'm going to turn that on right here. So if we look at existing coverage, what we did was we looked at coverage for both, well actually for all 4 operators, and then we have a combined view. So if I look at AT&T, this is how it looks. And the way to read this, as I mentioned, is not altogether complete, but it pretty much all the major roads are covered. Green is good coverage or performance, and red is poor, and then you have points in between as you go from green to red. So AT&T, for example, you can see they're very poor down here. They're poor right here on this section of road. And then we can look at individual layers. So the Sprint actually doesn't look so bad. T-Mobile is probably the worst. You see a lot of red, and it's the darker red, which gets down to almost no coverage. Verizon's pretty good. And what we did here is that there's many different ways that people want to look at this. One business model might be there is value in my location if I can co-locate, because then I can get all 4 operators on my location and they can share the rent, and then I can make more money because there's more people pay me rent, and the individual rents for each one of those can be lower, which then makes it a more interesting prospect for them to come onto my location. So that's one model. But in order for that model to play out, your asset or the location you're trying to rent has to be in an area that will help network performance for multiple operators. So what we did here was we combined them in a weighted algorithm. And let me just turn that on. And then again, it goes kind of like from this green, yellow, and then as you get worse, it goes to red. And the way it works is that if you see a very, very red spot like up here, that means pretty much all 4 operators had poor performance, because when we layer and stack those on top of each other in the weighted algorithm, everything will come out poor. And the very good sections, like right here, means that everybody had good performance. And then there are parts in between. So if it's halfway, that might be like 2 operators had poor performance, but 2 had mediocre performance, everything in between. So that's the way this map is working. So this is yet another individual layer. If we look close to our community center, it's not looking altogether that bad. You have an area down here that it looks like all 4 operators could need some help with. They all seem to be okay over here. Over here on this corner, there might be some areas, some opportunities that they could all stand some improvement. But it's not bright red, so it might just be a few out of the 4, maybe 2 out of the 4, or maybe 3 out of the 4. So that's another way to look at it. The other thing we looked at was we looked at a lot of demographic information as well. Now, one might say, what does demographics have to do with anything? But again, this goes back to some marketing concerns that we hear from wireless operators. So I'm going to zoom to this layer, and let me just describe what this is. So these squares or polygons on the map that we put here, and they're all different colors, these are census tracts or census blocks. And what we did with these census blocks is it represents a way for us to start aggregating a lot of these metrics and data sets that we have generated into a geographical area that seems to that's not too big, it's sort of small, and you can more easily make sense of things. Some very basic demographics that we can even look at here, and then combine with other things later, are things like income, population. So if I turn on population, this is color coded, and again it goes from low population to high population, from blue to red. So if you have some improvement that you could make somewhere around your asset, and you throw population, you could say, well, it's in a very high population area, and that could represent some additional value to a wireless operator, because you say this solution will help a lot of people because look at how many people live in this area. So it's just an added way of looking at your solution and how much more value can you bring. The other thing we look at here too is by income area. So this is looking at the median income of everyone that lives within the census block. And this could also be helpful. Again, it's about representing incremental value that you could bring. So let's say that it was very high income around this area where you have an asset. You could then go to the wireless operator and say, not only can I help your performance and help you offload capacity, but it is in a high income area where we know you have trouble getting towers, zoning, and permitting. And from their perspective, that would be value add, because you're also helping their high tier customers, those people that are on their the most expensive plans. They have the family plans, not the prepaid. And it also helps you because you can now start putting a premium on your location and the rent you could charge, because you have additional information that says I can charge a premium and probably get away with it for this location, versus another location that's in the low income part of town that is maybe not as valuable. But the key is not really, the key behind the analytics that we want to look at are not these individual layers. We want to start combining all these things to see what the final picture looks like. So let me turn this off. Okay, so we have reviewed traffic, the enterprise locations. The other thing that we're going to put in this analysis, and we don't necessarily have to do this, we do this in very complicated analysis, is we will generate a full 3D rooftop outline of the area of interest, as you see here. So let me turn off this Bing map. So within this area, we generated a full 3D rooftop outline. And there's a few reasons that we do this. One is so that we can model propagation as we start looking at different solutions that a wireless operator could use. We need that 3D rooftop outline to get to some very, very precise kind of next generation modeling of signal strength and propagation. But the other thing we can do is we can do a full indoor analysis using this rooftop layer. So what I'm showing on the screen here, and I'll just turn my aerial map back on, is if you remember the traffic maps that we generated, a lot of wireless operators are very concerned about the indoor experience. There is some literature out there that says, and I'm not sure that this is a actually true metric, but it says that upwards of 80% of all data traffic going over the network is generated when users are inside, when they're at an indoor location. By having this rooftop outline, this allows us to do a very precise indoor analysis to show the value to a wireless operator of an asset that you could have. So what we did was we took the traffic maps and we aggregated all that traffic inside each one of these buildings. And the color code of this is very similar to the other ones that we have, in that low traffic is the blue and high amounts of megabytes of traffic, data demand, is the red. And so certain things start popping up. So this shopping center is obviously hot, and as you look at the individual buildings of that shopping center, these two are hotter than this one, for example. This is hot, this is hot. And you can start seeing, and of course all this residential is mostly blue, it's low. You have a few houses here and there that they are doing some amount of data traffic versus other houses. This industrial area or apartment complexes obviously has more data traffic. But this really allows you to get indoor and show the value that you have to individual buildings and individual enterprise locations so you don't have to just make general comments and general remarks. You can get very specific about how you will be helping their network. Okay, so let's go now back to the the other thing I'll mention too is that we even broke down by enterprise building. So I just turned on enterprise versus residential. So you see residential is all this yellow, and then we put enterprise as the blue. And this will also help you slice and dice the data, so you can say, well, from this traffic map, there is this much traffic in X% of enterprise versus residential locations. And further on, I'll show you a few solutions. As you start planning these solutions, you can go back and evaluate and say, well, if you go with solution X, you will improve the indoor experience or offload X amount of traffic from the enterprise locations by this much, and you'll help the residential locations by this much. It's just different ways of slicing the data to show the value you're bringing. So let me show you the concept of a pain point map, or combining all these things into one picture. So I've shown you many things, and kind of in your head you're trying to look at probably, well, what is existing for operator coverage versus high traffic, and show me, you're trying to think what would make sense. If I can find all the locations perhaps that have high traffic, poor performance, high income area, and high population, that represents something that is of high value. And how do I look at that on a single easy way, rather than trying to put all that in my head and come up with multiple images? So what we do with the analytics is we start combining all these different things. So I have an example here of some different scenarios that we made up, which is I'm showing on the screen right now. So these are purely arbitrary. We just made up three. I'll highlight them here. Three possible scenarios that we made up. So we have multiple layers here that I showed you on the screen. So we had the household income, population density, we had coverage from the 4 operators, the combined coverage, we had the traffic maps, which is the data demand. We also included here some land use categories. So if I look at that, so show me everything that is residential, and that's pink. Show me everything that is forest, that's green. Show me everything that is commercial or industrial, and it comes out that color. And we can throw that into the mix as well. So in our first scenario, let us pretend that we called it high traffic for operator performance. Let's pretend that our business model is such that we want to co-locate, and we think we can show value by offloading a lot of traffic from wireless operators. So how do we use these layers to come up with, or paint a picture of where I will have value to, using this business model? So in this case, we put a weighting on each one of these layers, and the weighting, of course, has to come out to 100%. And well, it's high traffic, so let me put 40% importance on the data demand and the traffic layer, or layers. I'm not going to put any weighting on anything else, and then I'm going to put 40% on the 4 operator combined coverage, and let me just put 10% on these other two, population and household income. So what I'm doing is I'm combining these layers with a certain weighting. So what is the output of that? And I'm doing that so I can get one image out that paints a picture that represents this model. So when I do that, we're going to call that scenario 1. Let me turn that on, and I'm going to aggregate those numbers into those census blocks. So within each one of these census blocks, I looked at all those criteria, I weighted everything, and it came out with a value. And of course, in a weighted algorithm, our value is going to be somewhere from 0 to 1. It looks like this red one here, the max it got to was 87%. And to be that high, that means that those things had to have hit. There had to have been very high traffic aggregate within this census block right here, and operator performance had to be very bad within this block right here. And it also is relatively high income and a high population. And that's why this whole aggregate census block came out red. So I can see right here, well, not really in the community center that I have my asset. That, you know, if this census block that it was actually in was red, then I think you would be set. There is this area right here that's a little bit, you know, it's coming out pretty high. I don't know what percentile, it must be in about the 70th percentile. And then some areas over here, and then other things in between. So that's just one example of a scenario, and that's kind of the big picture all in one. The second scenario said, let's say I have a business model where I have an agreement with T-Mobile. They've already said, yes, we want to use your locations. And they're kind of like my anchor customer, so I really just care about them. And not only do I want to improve or offload capacity, but I want to improve network performance as well for them. So in this case, I put a 50% weighting on traffic, and I put a pretty high 40% weighting only on T-Mobile coverage, not the 4 operator combined coverage. So this is going to show me where there's a lot of data demand and also where I can improve, or where T-Mobile performance is poor. And there's just another total of 10% on these two demographics. So that's, we'll call that scenario number 2. So if that was actually the case, this is what the map looks like. This area is still common, but the rest of these things sort of did change a little bit. This one is still a little bit high as well. These kind of evened out a little bit more. They're not as high as they were in the other one. So it's a different picture, and the reason, and of course, so the answer really depends on the objective you're trying to achieve. It's not a one-size-fits-all. We made up a third one here that says, okay, I have an exclusive agreement with Verizon, and I really want to offload traffic. I don't want to, they have pretty good network performance, so I'm probably not going to try and improve their performance. It's more about capacity offload. And I really only want to focus on the high, you know, their marketing team has come back and said, we really will only pay for a solution that is focused on the high income areas where we can really recognize a lot of return on investment from that, because we can start selling better plans to the most you know, highest paying customers. So in this case, we started putting quite a few different weightings on things. So we said, you know, let's put 10% on median household income, 30% on data traffic. We want to put 10% on residential buildings, 10% on enterprise buildings, and we only want to put some percentage on urban, commercial, and industrial and suburban areas. So urban and residential, let's put 0 traffic on the open areas, 0 on the streets, and then the 20% on only Verizon coverage. So we have a lot of variables at play here. That's scenario 3. Let's see what that looks like. Oh, so if that was the case, you notice this entire area becomes a lot more hot than it did in the other scenarios. So I guess the point here is just that it's not a one-size-fits-all. Different business models require different analysis, and the big data that we use and the analytics that we do really tries to answer those questions based on very specific models of what you're trying to accomplish. Now let's look at solutions. So if we were to zoom in here, you might ask yourself, well, let's take it to the next step and actually help the wireless operator figure out what sort of solution we might be able to offer them. So we ran a few simulations. The first simulation we ran was, we said, okay, well, these pain points for the wireless operators are pretty far away from this community center. You're going to need to probably go with a macro site mounted up relatively high, so that you can go pretty far. If you remember, there was an area over here that had poor performance. So this area is pretty far away from this location, so you probably a small cell wouldn't work. Even a low high power but low height remote radio head probably is not going to work either. But let's just have a look. So we ran, we assumed that you put a macro base station here with 3 sectors on top of the community center. Let's see what that looks like. Let me just zoom out here. So this is looking at LTE coverage. It's called RSRP. it's a unit of power in dBm for LTE, and the green means good coverage. Orange is kind of okay coverage, and by the time you get to this really dark red here, that's at the bottom end of what you can achieve. So almost no coverage. If you want to think of it in terms of bars, green is like 5 bars, red is like 0 bars, and then you have everything else in between. So even if you were to put a macro base station here, we're assuming normal LTE power, normal configuration. By the time you get out here, you're really not helping much. But this will certainly, if you were to overlay this on, for example, our scenario 3. Well, if you're trying to cover these blocks, 1, 2, 3, 4, 5, this solution might work for you. If you're trying to cover a block that's up here, the solution probably won't work. The other solution we tried was a remote radio head mounted on the side of the building with 2 sectorized antennas pointing in different directions. Now, a remote radio head is the same amount of power as a macro site. The only difference is you're mounting it at about 7 meters or 25 feet on the side of a building, so you really can't go very high. So you can see here, again, if we assume 5 bars is green and this dark red is 0 bars, and then in between, you can see that with this lower height, you're pretty good at covering a neighborhood, but you're not going to go much further than a neighborhood or maybe 4 or 5 blocks. So here we're covering the golf course. We can cover, we can certainly help cover this medical center over here, and that's what you're going to get with this sort of solution. Then the other solution we looked at was just an outdoor 1 or 5 watt small cell. These are really meant for capacity offload. Small cells really don't go very far. They certainly don't penetrate buildings. They don't have enough power to do that. This one would really only help if there were some issues like in the parking lot or in this tennis court. Beyond that, a small cell, as you can see from this image, is not really going to go very far. So that would sort of represent the full turnkey design. You would first identify what are the issues. You would then figure out if you wanted to move forward, you think there's value here, and probably there's not a lot of value in this community center, as we just saw, for any operator out there. It's a little too isolated, and it's a little bit far away from where the pain points are in terms of capacity and network performance. But if you did want to move forward, then you start looking at, okay, what does the solution look like? How much is it going to cost? What's required? Is it going to be a macro site? And then you would go to the wireless operator and lay it all out on the table and say, here's the pain points, here's the problem I'm going to help you solve. And then, of course, you can even quantify and say, this is how much I'm going to help. This is how much I'm going to improve indoor coverage. This is how much capacity I'm going to offload. Now, our idea is certainly to, we're thinking, the best way, all this data is here, and our deliverables in this sort of project would be all this information that I just showed you. Some people have tools like this or similar type tools that you could view it. We have found another deliverable that we give out. Let me go here to deliverables. We tend to go with what's simple. So just about everybody has Google. So Google is something we can just give Google Earth files. Our customers can give it to their sales teams. They can distribute these to whoever they want to, and it's a very easy way to get data across. So for example, the venue data. This is some of the traffic map that lists how many people were in each location that I showed you before. We can open this in Google Earth, and then you can just have these files. So again, these were all color coded. So we see the red. There's a big red spot here. This is a Lowe's Home Improvement. It's a hardware store, number of people that were there, address, phone number, so on and so forth. Chuck E. Cheese. It's an arcade, number of people, etc. So this is one of the layers, and then you can start putting multiple layers. So we have the smartphone data demand layer 2 on top of that. And we showed you this. This was the first one we had shown in the map. Let's just zoom in. We, of course, lose quite a bit of resolution as we go to Google Earth than the other tool we're using. You can tell, but you can still make out. Remember the shopping center here. There was a lot of traffic here. There was a lot on the intersection, if you recall. Let's look at just one more. So we had the enterprise heat map of all the enterprise locations. So let me just turn off some of these other layers. So do you remember there was, so the community center was up here somewhere. Um, this was the medical center here. So the way this enterprise layer works is just another one of our traffic maps. So it's really hot on this building right here, which I guess must be the hospital. And the way it works is if you click on this, every single enterprise entity that's in that building will pop out, and then there's information. So I can click on one of these. The dental specialty group, it's a dentist's office. Here's their address. Here's their, if you want to talk to them, you talk to Sue Rika. She's the manager. Here's their phone number. Then we have Richard Mejia, MD, so he's a doctor. So you can see Office of Physicians. If you want to talk to him, Richard Mejia, here's his phone number, so on and so forth. And a lot of this really just has to do with us building the traffic map. And then of course when you go to the wireless operators, you have to show them everything that you can in order to establish the value that you could bring. Here's the haircuttery, beauty salon, etc. And the rest of these layers work that way. Of course, we even the coverage layers that we did, so the macro coverage, if you remember, we modeled or we did a simulation of coverage if we were to put a macro base station there. And you can see that as well in Google, so you can go here and see how well it's covering these buildings on the reds, the greens, how many bars of coverage you have. Okay, so that concludes this this demonstration. Again, just to review, the idea is we started off with the location. We had a question that said, is there value that we can provide to a wireless operator by either offloading traffic, helping with network performance, or some other sort of value we can bring? And with no information from a wireless operator, how do we make that decision? How do we see? So what we did was we used many different data sources. We did a lot of analytics. We combined everything together in some easy to understand outputs that started combining all these data sources in a way that really reflect, will it fit our business model or what we're trying to achieve. The deliverables were given in something that's easy, almost a catalog-like output. You can even import or say we have 500 locations across Florida, evaluate each one. Or you could even do the flip side of it and say, show me all the areas where there are problems and let me send some real estate people out to start getting leases for the sides of the building or for the rooftop, just again to be proactive rather than reactive. If you have any questions, please send me an email. My email is arubio@csky.com. Thank you.